Council for giving this opportunity to and inviting me to share some of the knowledge in this area, especially related to the indoor environmental quality, indoor air quality, and relation of that to COVID-19 as well. It's a very relevant topic at the moment. We are all going through a difficult time as a country. So um, as engineers, designers, and also facility managers, I think it's a very critical time where we have to also contribute in engineering controls to mitigate COVID-19 spread. Because this topic is being discussed quite heavily in other countries, especially countries that are already affected by COVID-19. And is going through a difficult time. However, we haven't still started in our industry to discuss in Sri Lanka about the engineering controls aspect, and all credit goes to the Green Building Council for always taking the initiatives to address these kind of issues and taking the leadership in this area. So we were very careful when we selected the topic of this talk, because we have used the word mitigate, because this presentation or this talk will not talk about elimination of COVID, which is something which is it's currently beyond our control. That is being dealt by the scientists and the health departments. So what we are trying to do is, since there's so many experts saying that the vaccine is a bit too far away, so we are trying to see how we can help as the building designers and engineers to mitigate the spread of COVID-19 in the environments. So let's look at the outline of the presentation today. So today we will be discussing about the indoor air quality related to COVID-19. We will also discuss about and learn a bit more about the actual characteristics of the SARS-CoV-2 or COVID-19, or within the last 6 months now we are calling it 3 names. We call it coronavirus as well. The sizes of the particles and what we are actually dealing with. We will study that as well. And also we will look at the guidance and recommendations given by international bodies such as ASHRAE and RIVA. We will discuss the forms of mitigation and see what we learn from the virus, how can we mitigate it through engineering controls. And also we will look at restarting our operations as facility managers. What do we have to do before we restart our operations after a pandemic like this? And also as building designers, how we should design not just for COVID-19, but also for viruses and other things which is beyond COVID-19. So whenever we find an engineering solution, we shouldn't find for the exact reason. We should always find for we should always think of the future as well, and what we get from it from the future. So looking at the indoor air quality, so this is some of the Environmental Protection Authority of US, which has stated 50% of the global illnesses are caused by indoor air pollution, and most of us, 90% of us, time is spent in built environment. And right now in the COVID situation, I think almost 100% of our time we spent in built environment. And what we always what we always forget is that how important is the air that we breathe, because normal human being who is basically at rest generally inhales about 11,000 liters of air, which is, however, like an athlete or someone who works out more would inhale more than that per day. So out of which about 20% is generally oxygen. So this shows how important is the air that we breathe in, and how easily we can get illnesses through air pollution. So I thought of sharing this especially for just to show you, this was actually taken. This data is before COVID-19 to show you that air pollution in China kills about 4,000 people per day, whereas air pollution in India kills about 100,000 kids every year. So this is even before COVID-19. So although we are very much used to wearing, we are not used to wearing the mask and taking these precautions. People who live in those countries, they have gone through this whole process and they have learned it the hard way. They have seen the air pollution happening, and they're very used to these precautions such as wearing mask and all. So when COVID-19 happened, they were already taking the precautions that we are taking right now, but still they got affected by that. So it is important to understand, especially as a developing country. In Sri Lanka, we are doing a lot of developments in Colombo as well. So it is important to understand how much we are contributing to the environment as well, and whether we are looking at the air pollution side of things. Otherwise, we will also have to learn it the hard way, the way that they learned. So looking at it, what we should look at is the pollutants. So what are the components, or what do we call pollutants in indoor air quality? So there's three categories that we can categorize them into: particulates, microbials, and gases. Then dust, then pollen falls under particulates, which is generally dead cells that you get and from humans and also animals, and also plants. Then if you look at the microbials, is what we will be focusing on today. That basically looks into the viruses such as COVID-19, but it's not just COVID-19, other viruses as well, molds and bacteria as well. And also the VOCs will be addressed in the gases category, where volatile organic compounds that emits through carpets and also paints that we use in our buildings. So that is harmful for humans as well. So most of these things, bad indoor air quality in a building is generally leads to sick building syndromes, where you get basically headaches and you get itchiness in your skins and nauseousness due to these kind of bad indoor air quality. So today we will focus mostly on the microbials. So when it comes to microbials, it is not just the viruses. We also look at the bacteria, molds, listeria, which is also a form of bacteria, bird flu, and things like H1N1 as well. And we will talk beyond COVID-19, which is what I think as in the industry we should address. So in order to address and look at the mitigation strategies, first we need to understand the virus and what are we dealing with. So when you know your enemy, you can easily, it's better, you find a better solution to fight them. So SARS-CoV-2 or COVID-19 is currently there's a lot of research being going on. So whatever we discuss today, we're going to discuss today might change in 2 weeks as well with the new research which will be coming out. But we also have to keep up with it, and we will try our best to always educate the industry with what we can do with the new research which is coming out as well. So what are the things that we currently know about COVID-19? So we will go into each detail of the virus first. So I thought of sharing this slide because I think in April, when the first COVID presentation was done, again from Green Building Council, about 3 pieces done by, I think, Professor Ajit Dialvis, he shared the same dashboard showing the number of deaths and number of infected globally. And in end of April, I think it's pretty much May, it was around 2.9 million global cases, whereas we've gone up to 43 million in 6 months' time. And deaths was around 203,000 globally, whereas now it's 1.16 million. Looking at Sri Lanka, we have definitely hit the second wave, hence why it is ideal time to even have this talk and discuss. It's more of a discussion as well. What we want to know is share our knowledge and also get inputs from the industry as well on their thoughts on this process, because we need to create this discussion in Sri Lanka right now and address this from the building levels as possible. So disease transmission, when we look at how this disease is transmitted, so there's a few main transition modes. Transmission mode, the main transmission mode that we will actually cover from indoor environmental quality is the airborne transmission. It comes in large droplets, which are emitted when you sneeze or cough or when you talk. These also emit aerosols. Aerosols are generally smaller droplets, predominantly less than about one micron. You also get through surface contact, like hand to hand or hand to surface and so on. I think that everyone is now familiar of since it's been, educated. We have been educated by the medical industry. There's also transmission through food and water, which is also possible, physical contact, and also through animal vectors. So still, when I remember when the virus was initially announced as a pandemic by WHO, aerosols were not even discussed as a transmission medium. It was mostly focused on large droplets and particles which are emitted when sneezing and coughing, which will travel distances about 1 to 2 meters. Hence why you have this safe distancing of 1 meter rule that we practice everywhere. So today's presentation, we will be focusing on the HVAC components that related to aerosol aspects. So this is a study done by University of Oregon in California, which they have modeled to show basically in a restaurant through just providing recirculation type air conditioning, how the virus transmits. So as you can see, it transmits a lot through recirculation type through aerosols. And this is another study which they show if you provide fresh air and exhaust instead of air conditioning, how much how the virus behave. Still, as you can see, there is some kind of transmission. This is because you will understand in the next few slides. This is because it depends on the airflow and also the particle size and how actually the air moves inside your building. So I will not be surprised to see in the future a lot of building services engineers or HVAC engineers working towards CFD analysis, so to look at the airflow movement within buildings. So this is that kind of a study which shows how the particles move with the air movement inside the building. So source of droplets and number of droplets. This was a study done in 1945. I think if you've been doing any research, much research in this area of HVAC, you would have come across this graph. It's been used by many. So number of droplets varies from about 10 droplets to about 100,000 droplets. And most of these droplets dehydrate to smaller sizes, and it actually depends on the relative humidity in the room as well. So that's why part of the mitigation strategy is to control the relative humidity for a desired level. So the diameters of these droplets can be less than 1 micron to even greater than 1,000 microns. However, the interesting study which has been done for influenza have found that 50%, more than 50% of the viral load is in particles less than 5 microns. it is important to also understand the respiratory aerosol dynamics. So aerosols are generally particles which are less than 10 microns that we are talking about. As soon as you cough, as you can see, there's a clear image. This is also very popular in the industry to explain the aerosol dynamics. So aerosol dynamics, it depends on the velocity and also the particle size as well. Small droplets remain airborne and may travel significant distances. Uh, but what will add to this is small droplets. If you have, it will also depend on the air conditioning system and also the airflow and the recirculation type systems to see how far these droplets can travel inside a room. Whereas large droplets settle before traveling long distances. So generally 1.5, it can go up to even 6 meters, depending on whether you're sneezing. So with this only, we have been requested to have a gap between 1 to 2 meters when we talk to someone. So however, even if you have a table fan or even a floor-mounted fan uh, in the building or in a room, that can also help the large droplets to travel longer distances. So that's why airflow within the building or within the space is very important when we are mitigating the transmission of COVID. So just to let you get an idea, because now we're talking about microns and different sizes of the particles. Why this is important in HVAC is because our mitigation strategies are very much linked to the particle size. For example, filtration, the filter type that we select is very much related to the particle size as well, and the behavior. So for everyone to get an idea about the particle size of the virus diameter of SARS-CoV-2 or COVID, human hair has the diameter is around 50 to 70 microns, so which is what you can compare it with. Then combustion particles and organic compounds, metals, it's about 2.5 microns or less. Dust, pollen, and mold is about less than 10 microns. Bacteria, you get even less than 5 microns. Influenza A, the diameter has been determined around, can go up to 0.12 microns. SARS-CoV-2 can also go up to 0.12 microns. So if you look at the filters that are defined in the industry, the filters are also the highest filtrated filter, which is basically a HEPA filter or ULP filter, is rated at 0.3 microns. So that's why sometimes just using a filter is not the solution for this. There needs to be other disinfection strategies that needs to be used in conjunction with the filters being installed in the HVAC systems. So COVID-19 transmission, again, this was also discussed in a HVAC forum in ASHRAE, one of the ASHRAE forums. What do we know about transmission and what are the controversies that are there? So initially when WHO announced this as a pandemic, they only mention evidence that point out to predominantly large droplets transmission at short range. That's how we got the 1 meter distance between and keeping 1 to 2 meter distance between each other. Possible fomite transmission was also mentioned, and however this tend to rely on the evidence coming from healthcare environment. So nothing was mentioned a lot about the aerosols or airborne transmission of droplets. So however, with some of the case studies and with some of the examples, I think now we can assure that there is airborne transmission and it is very much evident from some of these case studies. For example, Guangzhou, the restaurant, this is one of the first restaurants that one of the first studies that identified that there is an airborne transmission through aerosols, through air conditioning systems, where someone, through one person, about 20 people got infected, and also also basically there was a person who was even 5 meters away got infected by it. We'll come back to that case study because I've included that. It's a very common case study that is been used since it's one of the first which was identified. And also this choir rehearsals in one of the schools where participants out of 28 participants got infected despite distancing and hygiene guidelines they followed. Also, they've looked at the elevated concentrations of viral RNA detected in Wuhan hospital in air conditioning systems. RNA was also detected in the ventilation fans in one of the studies which was done in Singapore. And also SARS-CoV-1, which was, I think, around 2003 when it happened, airborne transmission was suggested as a possibility. Hence, I think COVID-2 is also very much similar to it. So it is very much possible that airborne transmission can also happen. So the next thing we did was we looked into the recommendations from different standards around the world. So mostly in air conditioning and indoor environmental quality, we follow ASHRAE standards, American Society of Heating, Refrigeration and Air Conditioning Engineers. REWA standards are also sometimes referred to for European standards or European body that basically came up with recommendations. So when we looked into it, ASHRAE came up with two different recommendations for non-healthcare buildings. I have included this here so that it is a document which is being published as well. So you can always refer to it and go through these recommendations. So for non-healthcare buildings, they recommended increasing the outdoor air ventilation, basically disabling demand control ventilation that normally we use with CO2 sensors and dampers, and opening it up to 100%. And if you can provide even more fresh air, they recommended that as well. Then they also recommended improving the central air and other HVAC filtration to MERV 13. So that is the highest highest level which you can achieve. So we will discuss about the minimum efficiency rating value of filters. So we have I think I have a separate slide on it that clearly we can discuss it there. So also they recommended to run the ventilation system for long hours, even 24/7 if possible. Add portable room air cleaners with HEPA or MERV filters. Also use UVGI, ultraviolet germicidal irradiation devices to kill germs in high density spaces such as waiting rooms, prisons, and shelters. They also mention about the importance of maintaining a temperature and humidity as applicable for the infectious aerosols. And both ASHRAE and REWA both discourage the use of energy recovery wheels during the COVID pandemic due to possibility of potential leak through the exhaust to the fresh air system side. So those are the recommendations for non-healthcare buildings. For healthcare buildings, on top of what they have recommended maintaining negative pressure for intensive care units where infectious aerosols may be present. For example, if there's any ICUs that treat airborne, COVID patients, we don't want any of the virus to come outside of that premises. So that area needs to be negatively pressurized. Normally, for areas where you don't need germs in, like theaters, be positively pressurized as well. But now in Hong Kong, you see after SARS, there's been some even theaters being converted to treat airborne kind of transmissions as negatively pressurized. And also it is important to maintain rooms with infectious aerosols and concerns at negative pressure. 100% fresh air exhaust for patient rooms. This can be COVID patients and also patients or whoever is also under quarantine in facilities. Use UVGI. This is also recommended. And in most hospitals, this UVGI is also used. They've also requested to increase the outdoor air change rate from 2 air changes to 6 air changes per hour. Going into REVA, most of these have been repeated in this standard as well. They recommended keeping the toilet ventilation in operation for 24/7 if possible, and also they requested switch the air handling units with recirculation to 100% outdoor air. Likewise, most of these are also been repeated in the ASHRAE recommendations as well. But when we went through this, we thought the importance of actually looking at how this will affect our current operations. Can we do these recommendations for existing buildings? How will it affect the systems that are already being installed? What is the effect of going and installing a high efficiency filter to your system? So we will discuss all this in individual sections because that is important because we can't just take a recommendation and go and implement in a building without actually understanding what's been installed there already. So this is, I think, a very popular hierarchy of controls, forms of mitigation, I would say. So it's a pyramid which is globally used, which has 5 sections starting from elimination to PPE, from most effective to least effective. If you look at elimination, right now it's not applicable to us physically to remove the hazard unless you lock yourself somewhere that the person who is affected, but now since it's spread, it's a bit difficult to do that. Substitution is also not an option. So most effective for us right now is engineering controls. If you take this triangle, the pyramid. So engineering controls, you isolate people from the hazard. So ventilation, proper ventilation. And it's not just engineering aspects, even architects taking a relook at the workplaces and rearranging the workplaces with the minimum distances which are required in buildings, and introducing physical barriers, exclusion of zones and things like that. Those are the engineering controls. We will discuss engineering controls in detail. Administrative controls like change the way people work, that is being already, I think, practiced in most of the office environments and also most of the companies to minimize face-to-face contact and have meetings like we have right now on Zoom or online platforms, social distancing, hygiene measures, reduce interactions, and so on. PPEs, again, which is safety glasses to masks. So these are considered as the least effective as it depends a lot on how the humans behave, individual behaves. So engineering controls, we have identified 5 main sections for engineering controls as air distribution, ventilation, filtration, disinfection, and temperature and RH. And out of what is been discussed in the 2 standards, we have summarized this as increased ventilation, even go up to 100% ventilation. Operate systems 24/7 for improved air and air treatment, bypass ERVs, increase filter efficiencies up to MERV 13 or higher, use UVGI and other technologies, which we will discuss today, and also control the temperature and humidity as per recommended values. So looking into the air distribution, as you can see, air velocities contribute a lot to the transmission and the distance that the droplet can travel. So it is recommended to have low velocities in your building. ASHRAE and REVA both has discouraged to use the rotary type heat exchangers, heat recovery wheels, due to the possibility of the particles being moved to the intake section. However, what we need to understand is there are implications by doing so. For example, reducing velocities, we need to first look at how it affects the distribution of air within a room. And also we need to see whether we have the required components in our ductwork and our systems to reduce that velocity to recommended levels. Heat recovery views, I think most of the buildings that we design now, office buildings and commercial buildings, we use heat recovery views to reduce the energy that is required to cool the outdoor air. So generally we use free cooling to cool the outdoor air to a reasonable level, and then we introduce that to the AHU. So as soon as you eliminate that from the design and from your building, there's a huge energy consumption that you will have to deal with. Ventilation side of things. So we normally in Sri Lanka, we design, and in other parts of the world as well, some parts we design as per ASHRAE standards. So we use ASHRAE 62.1 and 62.2 for non-healthcare buildings such as residential and commercial. And also we use ASHRAE 170 for healthcare facilities. So some of these recommendations which ASHRAE came out with during the pandemic are different to what is in the standards. So it is important to understand where they have been changed. This is the famous case in China. I thought of including this in the ventilation section because it shows how poor ventilation can spread the virus easily. For example, you see a restaurant in China, in Guangzhou, where they've used recirculation type air conditioning instead of fresh air. And as you can see, from one person, about 20 people got affected. And if you look at the diagram, it shows A1, which is the patient who initially, patient number one, got affected on the 24th of January. And even people who are away from them due to this recirculation of air got affected within the next 2 weeks. To show the importance of ventilation, what additional fresh air will do is it will dilute the contaminants, and basically what you see here is even if you look at the ppm levels generated in a room when you go to sleep for 2 adults and child, if you don't have proper ventilation, it can go up to 2000 to 3000 level. Recommended level is around 1000. So this is what we are trying to address. And most of the buildings in Sri Lanka and most of the places, what we have seen is a lot of people, buildings have been designed for taking into infiltration of air, but even sometimes you think there's only few people in the room, but when you design it, when you actually see the building operational, during the operational stage, you see about 5-6 people in the room. So you need to measure the CO2 levels and bring in the necessary fresh air to these areas. Exhaust and pressurization, very much related to buildings and also to healthcare buildings as well. So we also looked at in applying the recommendations that ASHRAE and REVA, what will happen to the energy consumption in buildings and what are the challenges that we will have to face. So it is clear when what we did was we looked at one of the buildings, one of the office buildings that we recently designed, and we took one of the spaces and we calculated the cooling capacity for recirculation type, 20% fresh air, which is generally recommended fresh air rate, but you can calculate the actual fresh air rate as per ASHRAE standards. And also if you bring in 100% fresh air, what happens to the cooling capacity of the equipment? So it, as you can see, it has almost increased by at least 3 times. So when we do these kind of modifications to the design for the systems, we need to see whether our installed equipment or the coil sizes in AHUs, whether the capacity is adequate to cater for that kind of a load. And another thing we need to understand is by changing, making changes to one system, such as ventilation system, you will have to make changes to other systems such as electrical. which takes into the load, calculations, the capacities of MEP or mechanical equipment which will be installed. So it's not an easy task. It's not like switching on or switching off something. You need to look at all the system specifications and also as-built drawings, and sit down with the design engineers who design the building and see what kind of changes that you can do and how it will affect your building. This is regarding isolation rooms and ICUs. So isolation rooms, ICUs with COVID infected patients should be negatively pressurized. Adequate ventilation, at least 100%. They sometimes, they even recommend 100% fresh air to be provided directly to this space, especially for healthcare facilities. And exhaust to be directed to outside without any recirculation. Proper temperature control and humidity is also recommended by ASHRAE. So the next form of mitigation is using filters. So in the industry, there's mostly 3 types of filters. We will focus mostly on the mechanical filters, as electronic and chemical filters are not currently that popular in the industry, or maybe it is popular only for certain applications, but we will focus mainly on the mechanical filters. So it is important to understand the filtration mechanism of these filters and see how it blocks the particles from entering your spaces. So there's 3 main mechanisms that filters use. One is straining, impingement, and diffusion and interception. Straining is where when the particle sizes are generally larger impingement is the inertia. Due to the inertial forces, the particles collide with the filter medium so that it gets clogged there. Diffusion is when you have very small particles. So these are like germs and viruses. So you see this a lot in HEPA filters and filters that are used in medical industry. So where it starts among the particles move in a random motion, and then it diffuses to the filter surface. And when you have a higher flow rate, the diffusion rate is low. So that's why you see in HEPA filters, or the filter sizes are quite high, big, or you have a very low velocity going through it. Interception is again when the particles, when the filtration is done to particles that are finite in size. So when it comes to mechanical filters, there's a few main types. We have panel filters, which has a rating of around MERV 4 to 7. That we use sometimes as pre-filters. Then we have bag filters, which has a MERV efficiency of about 12 or plus. And then we have cartridge rigid cell box filters, which generally rated at MERV 12 to 16. Then we have high efficiency particulate air or HEPA filters, which we use in medical industry for which has a rating of about 17 to 19. And also we have ultra low P particulate air or ULPA, which is the highest rated filter by MERV, which is around MERV 20. So it is important to understand the filter selection procedure, since if you're planning on changing your filters as per the recommendation, first you need to understand how these filters are selected. So as you can see, filter efficiency, pressure drop, and capacity of the filter are 3 main aspects that we consider when we select filters. Filter efficiency is the particle removal efficiency of the filter with the particle diameter. As you can see, this graph clearly shows that MERV 13 and above will have an efficiency of particle removal, higher particle removal efficiency of for particles less than 1 micron or closer to 1 micron. So we use a standard called ASHRAE 52.2 for testing and of the MERV to get the MERV rating for the filters. Regular air filters are not designed to prevent spread of viruses, such as filters such as MERV-8. And also, you need to also consider about the pressure drop. Just because there is a recommendation on increasing the filter efficiency, you have to look at the pressure drop across the filter. So when you introduce high efficiency filters, there is a larger pressure drop. Pressure drops going up to even 250 pascals for HEPA filters, which is generally, just to give you an idea, if you design a HVAC system, with normal filters, your total pressure drop will come up to about 300 to 500. Of course, it depends on the duct components in the ductwork and also the ductwork path and the equipment. However, just by adding a HEPA filter, you will increase the pressure drop to 250. So what you need to understand is whether your fans that are in the AHUs are capable of handling that kind of pressure drop, because otherwise you will not get the required airflow through them. So then the solution to it can be introducing a return air fan to your return air side with return air ductwork with a HEPA filter or MERV 13 plus filters. So that can be act as a solution. So that's why there are solutions that you can work out, but you need to understand exactly what your system is and the specifications of your equipment, which are already installed on site. Capacity of the filters and the thickness of it, the size and the thickness is based on the airflow rate and the particles that will be filter changing rate. Then looking at the MERV minimum efficiency reporting value, as you can see, MERV 1 to 20, 1 being 1 to 4 being filters that we will use for bigger particles, filtration of bigger particles, whereas if you look at MERV 17 to 20 is filters for viruses and like carbon dust. So these are like HEPA filters and ULPA filters. As you can see, the problem here is even those filters are rated at 0.3 micron. So if you look at the COVID, which is COVID virus, the diameter, it is about 0.12. So that's why just the filtration will not give you the 100% elimination strategy or like mitigation strategy. You will have to use filters in conjunction with the disinfection technologies such as UVGI or other technologies that we will be discussing in the next few slides. This is an interesting study done by Stefan and Azimi about building environments. So what they did was during influenza, they looked at the filters versus increasing 100% of ventilation up to 100%, the difference in annual utility costs. So what you can see is even by increasing the filtration rate, so they have done this for 3 different areas in the States, and as you can see is increasing the filtration efficiency still is much better than providing 100% fresh air to the space according to their study. Humidity. This table is figure is very important. As you can see, it shows you the optimum zone that the humidity to be maintained in a space to avoid bacteria, viruses, and other diseases that will be transmitted through air. So this is the recommended RH anyways from for office spaces from ASHRAE is around 55 plus or minus 5. So optimum zone, if you maintain at the same level, I think it is okay. But there's some studies now have been done. They say even coming down up to 30 is a good practice, but there's no scientific evidence behind it. Looking at disinfection technologies, UVGI, ultraviolet germicidal irradiation is one of the technologies that is being used commonly now in the industry. We use UVC with a wavelength of 254. So what this does is it alters the DNA by penetrating the membranes and the nucleus and attacking the virus at a molecular level so that it will not be able to reproduce. So as you can see from this graph, the optimum germicidal effectiveness is at 265. However, germicidal effectiveness at 253 is also recommended as an efficient point to start in UVGI. So UVGI technologies have been used. There are different forms. You see these in hospitals sometimes, upper room air systems. So it breaks down the room into different zones. This is specially used when you have return air diffusers in your ceiling level. It creates a zone where your return air is being sucked out. So that zone, you provide UVC radiation so that it kills the germs in that zone before it's been introduced to your air handling units. However, you have to be very careful, and you have to take necessary precautions, and proper design needs to be considered when you're installing this, because this could be very harmful if you have human contact with UV. So UVGI is also introduced in ducks and AHUs and robots. We have a different opinion to this, which I will come into that. So it has been recommended to install this by certain areas. You see this being installed in AHUs. It is good to install this in AHUs, especially to keep your cooling coils clean. However, if it's about attacking the virus using UVGI, you need to look at the kill dose or the CT value of the virus. So as you can see, there's a time component to it, the exposure time. If you have a moving air, you have minimum exposure time. So it is not that effective when you install UVGI in the duct flow path or in the flow, airflow of a HVAC system. However, for surface sanitations, disinfection, this can also be recommended. Deploying autonomous disinfection robots, I think this is practiced now in some hospitals abroad, where when infected patients occupies a room, and when they leave, before another patient is put in, they send in these robots and disinfect the areas. These are also now recommended for areas where there is large gatherings, like for example, if you have lecture halls or classrooms that have been used. Once a classroom is used, you can send in a disinfection robot and clean the air and the surfaces before another class is being started. Bipolar ionization is also another technology, disinfection technology, and it is important to understand the working principle behind it, because it's very effective in certain applications. So it consists of like low voltage ionization tubes, which are being introduced to the airstream, directly to this airstream. And when a current is applied to the electrodes of these tubes, it creates an ionization field around those tubes. So when you supply air through them, you generate positively charged hydrogens and negatively charged oxygens, positive and negative ions. So this purifies the air in 3 different ways, and all 3 ways help this, especially the transmission of COVID-19. So first way is sterilization. So this is when positively charged H ions and negatively charged oxygens combines to generate OH radicals. And as you can see, there are proteins spikes in those viruses, surface of the viruses, which contains H ions. So what these hydroxyl radicals do is they steal one of the hydrogens to make H2O, and by doing that, it affects the virus in a molecular level in using sterilization. Agglomeration is a fairly simple way of understanding this. Is positively and negatively charged ions. They combine to get larger particles that can be filtered through normal filtration systems in the building. So heavier particles can also drop out to the floor, out of the breathing zone as well. So agglomeration is also a very effective method of purification using BPI. Oxidation, here again, it's not just COVID. What this does is the bipolar ions, it surrounds the VOCs and breaks down its hydrogen chains, reducing the complex compound into H2O and CO2, which are measurable. H2O and CO2, which are measurable. Yeah. So some of these technologies actually, not just for COVID-19, it improves the indoor air quality in spaces. So we have one more disinfection technology that is common in industry is photocatalytic oxidation. This is again the photo side of it is the UV light, and then it uses titanium dioxide as the catalyst to oxidize the chemicals and odors. It's commonly used in industrial applications, and again, it keeps the coil clean and also kills the VOCs. So some of these technologies are introduced to the systems. I think Green Building Council will also take necessary steps forward to even maybe encourage using these systems in your building, even providing green points so that it will encourage people to use these systems in the building and hence improve their indoor air quality. I have few slides. I think I'm not sure whether Professor Priyan is also has joined the forum. So there's some R&D work that we are doing with Professor Priyan Mendis and the University of Melbourne. So developing two main components or products. I cannot give too much information about it because it's a product that is under research and possibly going for a patent. So, but we will share some of the data. What this product is it's called BID, Building Integrated Disinfection System. So BID works by generating a mist with two different application modes, like air purification and also decontamination mode. And it has a specially engineered solution agent. So it generates a biocidal atomized solution mist with a centrally located plant. So what we are basically looking at is another system that will be introduced to a building, a normal building design, like a sprinkler system that you will introduce with a centralized plant that will detect the viral load and then disinfect it using the mist. There's also research being done in the area of virus detection or biosensors. It determines the viral load and activate the disinfection mechanism or alerts the occupants in the building. So this is there's ongoing research on the detection radius and also the sample volumes of the fluid. We are working very closely with the University of Melbourne and Professor Priyan Mendis on these matters, and also these can be used in detection as a detection mechanism for group of people in public spaces. For example, some people coming in from airports, we can get them to come to a room and then check the viral loads in the room and also disinfect the room at the same time if there's anyone, if the viral load is too high, and also identify the patients in the process. Like other detection systems in the building, we have heat detectors, smoke detectors. We also have CO2 detectors, carbon monoxide detectors, and so on. So I think you will soon see a biosensor as well. I think Professor Priyan is very much into the this and also doing a lot of research in this area. We will probably be able to hear from him at the end of the presentation. So before we end, since it's almost 7, before we end, I want to put some questions into the forum and also take this up. It's not a blame game or anything. It's basically we have to see whether what we are doing is right. Are the quarantine centers and temporary hospitals safe? Not just in Sri Lanka. I'm talking about all around the world. Have we considered the ventilation requirements when converting these facilities? We convert some quarantine centers, some areas into quarantine centers, and even if we run out of hospital spaces, beds, we will have to convert this into some spaces into hospitals. But in doing so, we should make sure that we look at the proper ventilation rates. For example, if there's a hospital, we need to look at the pressure differences in affected patient areas and non-affected patient areas, and things like that. And also, if you're converting sports arenas or also warehouses in the future, you will need to look into the proper ventilation strategies, because whether the ventilation rates that are already in those facilities are adequate and proper ducting is done and proper precautions are taken for these kind of facilities to be converted. How to reopen our buildings? This is very important, because recommendation for building readiness. So if your building is closed due to affected patient, or even as a good practice, if you're even pre-opening after COVID, it is recommended to change your HVAC filters or clean them properly and use disinfection strategies to sanitize all the spaces. It is recommended to run the fresh air and exhaust system at least for 24 hours properly to do building flushing, and modify the existing systems to accommodate new engineering controls such as filtrations to UVGI or bipolar ionization. But in doing so, make sure you look into the existing as-built drawings and also specifications of this equipment, and to see whether these controls, engineering controls, can be included in your existing buildings. If you haven't still, if you're in the process of building something, I think building a new building, I think it's about time you sit down with your clients and also look into and also address these issues with them and explain to them the benefits of it and try to get the best systems in place to mitigate the transmission of COVID-19. So finally, it is not the start, and it will never be the end, because even if we fight the COVID virus, I'm pretty sure there will be other challenges that we'll face in life when it comes to indoor air quality. So we have to think beyond COVID when we are even doing research, or even if we are coming up with engineering solutions to mitigate the transmission. Finally, I would like to thank the frontliners, the doctors and the medical staff and the forces, the police, and also people who are helping to keep this economy going for the work that they do, and also putting their lives forward and protecting us in these difficult times. I think we can open the session for questions, if any. Thank you.
Thank you very much, sir, for that interesting and knowledgeable session. We hope you all received good comprehensive knowledge on this area of concerns from the talk. If you have any questions, you can direct them to Dr. Tarendu Samrasinghe. Not only questions, you can express your feedback as well.
Can I make one comment?
Yeah, sure.
Yeah, Professor.
Yeah, thank you. And just for congratulations, the Green Building Council for organizing this very, of course, really timely, and you're all with us with the situation. Even in Melbourne, we went through that about a few weeks back. So I'm sure the Sri Lanka will be under control. Again, Dr. Tharindu, as I put in the chat, excellent presentation, and I think that you explained very clearly. And I haven't seen a talk like this around the world. I've listened to a few. So you have done all the hard work getting that information. So I think and also thank you for acknowledging the joint work. It's really that's cutting edge work. Really that collaboration with Melbourne and with you and BSEC, I think that'll be extremely important. Now, just to add to that, I think it's quite important. Even COVID goes away. We all hope for that, but also that we know that there'll be different types of COVID, so it's not going to go away forever. I think it's really becomes a routine thing. But at the same time, I think even much more dangerous coming up is this antibiotic resistant bacteria. So I think that's why all that ventilation systems are becoming extremely important. So my question is more on to you, Dr. Tharindu, is more on now you mentioned about the air coming in, the fresh air coming in. That's an extremely important point, because 3-4 years, a few years back, we all went to just to tighten up the buildings, completely seal the buildings. Now we are going the other way around. So getting the fresh air back into the buildings, which is a very good thing. And we never expected that. We were just going totally other way around. So sealing all the buildings. Now, what do you think? How do you change from one thing to the other, getting that fresh air? What are the implications on buildings around the world, not only in Sri Lanka, but around the world? So,
yeah, Professor. I think what I can say is, as countries like our countries, we are actually privileged with these temperature conditions and all, but there's extreme conditions when it comes to other countries, where, especially even if you take Melbourne and European countries, where heating is a major requirement. So more fresh air you take in, you will increase the capacities of your HVAC equipment. And this is clearly a challenge especially for the existing buildings and facility managers of those existing buildings, because more fresh air you take in, your equipment capacities will increase. And even if you decide to increase the capacity of your HVAC equipment, is your electrical design being done to cater for that? Is your main connections being done to cater for that kind of an increase? What is the spare load that you have? So there's a lot of things that you need to consider before you actually do any change to any of your systems. So of course the recommendations are there for you to look at, and also to see whether you can implement, but it's not recommended to blindly implement any of these recommendations without doing a complete study of the as-built drawings and how the system is operating currently in the building.
thank you very much, Dr. Tharindu. Thank you.
Dr. Tharindu?
Yeah.
I have one question. Only if it's central AC, it's fine to change the filters and all. How about the split ACs and packaged AC?
Yeah, as I said, when it comes to package air conditioning systems, still you can introduce filters as well, but of course your fan capacities needs to be checked, whether the fan capacities or the static pressure that the fan has, generally it is low, so you will not be able to achieve it. Then you can introduce a fan to your return air side, and with a separate fan for the return air ducting, and you can pass that load into that fan as well. When it comes to split units, I have seen recently, I think I'm not going to mention the supplier here, but they've introduced even a fresh air connection for wall mounted split units. I will share those details with you probably later on. I can send you the link. Recently, I was reading and I found even split air suppliers, conditioning suppliers are now thinking of bringing in fresh air to the buildings. But for wall-mounted splits, definitely you can't go with higher filters than that.
Yeah, thank you very much. Okay.
So we can accept 2 or 3 questions as well.
You're also welcome to, I think, Situmani, you can share my email if anybody wants any details or any questions, you can send it to me through email as well. I will leave the email address in the chat.
Sure, sir, I will. So if there are no more questions, we can wind up the session with the time constraints we had. And if you have any questions, you can write them to events.gbcsl@gmail.com as well. And we will forward it to Dr. Tarindu Samarasinghe. Thank you, sir, again for sparing your valuable time to enlighten us. And thank you all for participating. And I would like to announce you that Green Building Council of Sri Lanka has arranged have few programs for you during this period. There will be 2 online programs in the coming month for university undergraduates and construction industry professionals separately. Please do register for them when the links are shared on our FB page and join with us to obtain a qualification as well as collaboratively drive towards sustainability. And have a good night. Stay safe.
Thank you.
Thank you.
Thank you, Siddhini. Thank you.
Thank you.